Hello dear students, welcome to the online classes. Today the topic of my talk will be sterilization and disinfection part 1. We will continue this and as a second part of this part 1, and this class will be intended for MLT second year, ACOT second year and ACOT third year. So what are we waiting for? Let's begin. So in case of sterilization and disinfection, we have already discussed in the previous lecture about the physical methods of disinfection. That is sunlight. We have talked about sunlight, we have talked about heat, we have talked about vibrations. So this end is already covered in the first lecture. Okay. So what we are going to cover in this lecture will be the rest of the part, that is radiation and filtration. So that will be the topic of this lecture. And then we will start with the third part that will be coming soon, that will include the chemical one. So today we'll be focusing on radiation and filtration. So let's go on. So as far as the physical methods of sterilization are concerned, we have so far studied the sunlight, we have studied the dry heat and moist heat comparatively, and we have studied the vibration. In this lecture we will be particularly focusing on radiation part and the filtration part. Okay, so let's move on. So when you look up on the radiations as such, you will find out that the visible spectrum lies around from 300 to 700 wavelength. So what you see on the left side of the visible spectrum, there are high energy radiations. You might have gone through the formula that energy is equal to H and frequency is V. So you will see H is the Planck's constant. So energy is directly proportional to the frequency, and frequency itself is inversely proportional to the wavelength of the electromagnetic radiations. So what you are seeing here is if you make it a structure like this, you will see that as we move towards the right, the frequency is decreasing. So what is the wavelength? So wavelength you can define as the distance between the two crests. That's the wavelength. So what if we can consider the wavelength here, the distance between the two crests of the wave. So as the wavelength is less in this case, so the frequency is higher and so is the energy. So as we move towards the left side of the spectrum, you will get more energetic radiations. So we'll be talking about these radiations today. And when you go to the right side, you will see that the infrared radiations, they are used in your electric iron. They are used in your microwave ovens, although the microwave is not used in that oven. So it is the infrared radiations, microwave oven. So then as you move towards there, the wavelength is going to get more and more higher. So that will include your radar that's fitted with many airplanes, and then FM, you can hear the many songs on it. We have TV and then the short waves and other waves. So on the left side of the spectrum, you will find that these are the energy rich radiations because they have high frequency based on the formula of energy is equal to H into frequency. Okay. So when we talk about radiations now, so radiations, they do not generate any heat. So as such, they are called as cold sterilization. And particularly fruits and vegetables are irradiated with these radiations to increase their shelf life, particularly in the European countries. So when you talk about the types of radiations, there are two kinds of radiations. One is ionizing radiation and another is non-ionizing radiation. So you should understand what ionizing means, to make something into the ions. So ionizing radiations, they are high energy radiations and they have a good penetrating power. And they are further divided into, ionizing radiations are further divided into two types, that's electromagnetic rays and the particulate ionizing radiation. So we have electromagnetic ionizing radiations and particulate ionizing radiations. So in case of non-ionizing radiations, they are low energy rays and they have poor penetrative power. So in this case, ionizing radiations, they can provide us better sterility. So moving ahead, so when you look at this electromagnetic spectrum as a whole, so what you see here is, so this is your electromagnetic spectrum, which includes all the radiations that are secreted by, or they are emitted by the light. And ultraviolet lights, they are high energy radiations, X-rays are high energy radiations, and the use of electrons is used in the electron microscope because electrons have the same wavelength as that of the X-rays. So we use electrons in electron microscopes, and we also use them as ionizing radiations. So these electrons, we can shoot them up. Onto the surface so that we can decontaminate the surface. So let's talk about these ionizing radiations now. So when you talk about electromagnetic radiations, you have, as I showed in the previous slide, gamma rays have very high frequencies, so they are highly energetic rays. So in this case, we can use them for either disinfection or sterilization. So electromagnetic rays, such as gamma rays, which are completely to the left of the spectrum, they emanate nuclear disintegrations, and this nuclear disintegrations can give rise to different radioisotopes, for example cobalt-60 and cesium-137. So they have a very high penetrating power because they will be more energetic, based on this formula that energy is equal to hv. So more with the frequency towards the left, the more will be the energy. So more energy, so high power penetration. So then the electron beams. So electron beams, we will use it in particulate radiation, particulate ionizing radiations. So compared to the particulate ionizing radiations, the electromagnetic, your gamma rays are more powerful. But one problem is there, that they require a longer time for exposure. Okay, so these high energy radiations, they damage the nucleic acids of the microorganisms. So when the nucleic acids, the genetic material, is destroyed, so it means microorganisms, either they will be disinfected, or they will be stopped multiplying, or they will be killed. With a dose of around, when you give it around 2.5 megagrad is the unit of radiations, it's enough to kill. It means it is a bactericidal radiation. It can kill bacteria, it can kill fungi, it can kill viruses, and it also is effective against the spores based on its high energy and more penetrating power. Commercially, when you look at it, it is being used for sterilizing many different kinds of things which we use in the laboratories. For example, petri dishes, your plastic syringes, the antibiotics, vitamins, particularly vitamin B1, riboflavin, B2 riboflavin, and B12 cyclocobalamin, which is used for the production of the red blood cells, and also used for production of hormones and glassware and the fabrics. So you can sterilize them by using gamma radiations. So now we have talked about the advantages. What are the disadvantages of using gamma radiations? Well, unlike the electron beams, which are particulate in nature, they can't be switched off. Okay, so we don't have any switch so that we can switch off the electromagnetic gamma rays of our own choice. The second is glassware tends to become brownish in color if you use gamma rays, and it also loses its tensile strength, particularly in the fabrics. Gamma radiations, they also impair the flavor of certain foods. If you radiate certain foods, for example fruits, with the gamma radiations, definitely you will see that they may lose the flavor. So in order to evaluate whether the sterilization by gamma rays is complete, we use this as a control, that is Bacillus pumilus E601. So if this is absent after this process, so it means the sterilization has completely taken place. But if it grows after irradiation, it means the sterilization has not completed. Okay, moving to the next slide. So another way of ionizing radiations are the electrons. So we call them as particulate ionizing radiations. As I said, that electrons have the same wavelength as that of the X-rays, so they have been used as in electron microscopes, as well as using radiating this energy for the sterilization or discontamination of the particles. So electrons, as I told you, they are subatomic particles. They have the both wave and particle nature, but here we are talking about its particular nature. Okay, so electrons usually orbit around the nucleus of an atom with the same wavelength as that of the electrons. So when the wavelength is same, it means the energy will be same. So they are generally negatively in charge. Electrons, we all know that they are negatively in charge, and they are much smaller than the nucleus, because if this is the nucleus of any atom, then you will see the electrons are moving around the nucleus. So the example of this will be like if nucleus is the sun, then electrons will be like our Earth, rotating around its orbits. Okay, so they are much smaller than the atom. So electron beams are particulate in nature, because here we are talking about particulate matter, but they have wave nature also, so they are dual in nature. So what we do in this, how we sterilize the things is we use high-speed electrons, and it means we have to speed up the electrons, and this speeding is done by a linear accelerator that's happened from a heated cathode. So cathode, it's negatively charged, and anode, it's positively charged. So when they are being speeded up with the help of the linear accelerator, electron beams, they are employed then for sterilizing many kinds of articles, and many of them are like syringes are there, gloves, dressing packs, food, and many other pharmaceuticals. Okay, in this case, when you use electrons as sterilizing agent, so the sterilization takes place very fast. That can be as compared to your gamma radiations. This one is a little bit fast and can complete within few seconds. But in case of particulate, ionizing radiation, that's electron, we can also have an advantage of switching it off when we don't need it. So electrons can be, showered. If this is a particle, electrons can be showered onto the matter, and it can be controlled by a switch. So whenever we switch on, they will shower. Whenever we switch off, so they don't. In this case, it is completely opposite of that of the gamma radiations, where we don't have any switch to stop and see. And sterilization takes place very fast as compared to the gamma radiations, and there are some disadvantages as well. Okay, so this disadvantage here is the poor penetrative power. Okay, because it doesn't have the gamma radiations are higher in energy than the electrons, which are the same wavelength as that of the X-rays. And also we need a sophisticated equipment for that, which is not used, which we don't require in case of gamma radiations, because there we use the disintegration of the atoms, which are radioactive in nature. So there we cannot we cannot control this. So let's move on to the next. So now we are talking about the non-ionizing radiations. In this case, we will be talking about the ultraviolet rays. So you might have seen many people, particularly in the European countries, they flock around the sea beach, and for giving a sun bath. So when the sun is there and this electromagnetic radiation spectrum comes up, so along with it, UV radiations also, come on can hit people. So in this case, they use sunscreens to protect themselves from the UV light. So different sun creams come with a different protective power against the ultraviolet rays, because it can particularly lead to the skin cancer that is known as skin myeloma. Okay, so if it can cause cancer in humans, definitely it will have some effect on the microbes as well. So let us see them in the non-ionizing radiations, what they can do. So in case of non-ionizing radiations, what we are seeing is it includes the spectrum of ultraviolet radiations. It also includes the visible light, the infrared, microwave, radio frequencies, and external extremely low frequencies. So because they have very low energy, so this is the one which can get us our desired effect of disinfection or sterilization. So in many cases, it has the wavelength, the microbistal wavelength of UV, it lies in the range of 200 to 280 nanometer. But the maximum effect can be achieved by using or 260 nanometer of wavelength. It's very effective in that case. And UV rays, they are generated using a high pressure mercury vacuum lamp. So in this lab, if the wavelength is set at 260 nanometer, they can be absorbed by the microorganisms at its maximum. So the 260 wavelength can have a maximum absorption ability, and it can penetrate the microorganisms that results in germicidal. So it kills the bacteria. Whenever the term cidal comes, it is killing. Whenever the term statics comes, it is not killing, it's stopping multiplication of the bacteria. So how do they do it? They particularly induce formation of thymidine dimers, in which case the DNA will not be able to replicate. So when it's not able to replicate, it means it's going to die. And it also causes some DNA damage, which ultimately inhibits the DNA replication. So microorganisms such as bacteria, viruses, yeasts, okay. For example, single cellular yeast is Saccharomyces cerevisiae, which is also called as baker's yeast. Then viruses, different kinds of viruses, they can be either DNA viruses or they can be RNA viruses like coronavirus, okay. They can be different kinds of bacteria like gram-negative bacteria, for example E. coli, gram-positive bacteria, for example B. subtilis, which is a spore-forming bacteria. So when they are exposed to this effective UV radiation, they are inactivated within seconds. So it's also a fast method, and that was very similar to that of the electrons. So since UV radiations, they are not able to kill the spores, so what we can say is UV radiations, they are not cidal, they can be a static form, they can be bacterial or microstatic. It means it's stopping the multiplication, and it's also not effective against the spores. So as such, we can use it not in for sterilization but surface disinfection, okay, stopping the multiplication of the microbes. Okay, so what are the applications of the UV light? So there are applications as well as the disadvantages. So let us compare it on this slide. So when it comes to the applications, you see that UV rays are employed for to disinfect hospital wards in the different kinds, in the private as well as the government hospitals. They are used in operation theaters where the surgery is about to take place. They are employed in virus laboratories, particularly in the biosafety cabinet. We have a UV light, and we can start it before 15 minutes when we are supposed to work on it. It can also be used for disinfecting the corridors. Now, what are the disadvantages of the UV light? First of them is it has a low penetration power, so it cannot be coincidental. It is a static. It means it is not sterilizing anything, but it can disinfect. So the reason being is it doesn't penetrate the glass. It cannot penetrate the paper, plastic, and any other organic material like dust. Prevents its reach. The UV bulb has a limited lifespan, so we have to replace the bulb when we are working in the biosafety cabinet. We have to replace it say around every 3 months. And some bacteria have their DNA repairing enzymes. So whenever you shed your UV light on the microorganisms, they can evade this disinfection, because within the microbes they have some DNA repairing enzymes. Particularly UV lights, because they damage DNA, So some bacteria have these repairing enzymes, so they can overcome the damage that's being done by the UV rays. And if you're working in the hood, and you should be you should be protected with your gloves, because it can be harmful to skin and eyes. As I told you, these radiations can cause skin cancers, particularly skin myeloma, as I told in the previous slide. Myeloma. Okay, moving to the next slide, we come to the next part, that is filtration. So in this case, you can understand the word filtration. It means if we use something, which has small pores, okay, and we pour our material of interest, for example, a liquid broth in which you are culturing your organisms. So what it can do is filtration will only stop the microbes from passing through it, and you can collect your liquid here. So based on the porosity of these filters, they have different uses. Okay, so let's move ahead. In case of filtration, you will find out that they don't kill microbes, as I told earlier also. They don't kill, but they don't kill, so they can disinfect something. So they can only separate things. So membrane filters, which we commonly use in our labs, they have different pore sizes ranging from 0.2 to 0.45 microns. Let me tell you that the overall dimension of an average bacteria is around 1 micron in size. So if you use the filters which are less than 1 micron, that's 0.2 to 0.545 microns, we can easily filter out the bacteria out of our broth or liquid which we are using in the lab. So they can remove these particles, as well as so that we don't, solutions that cannot be auto cleared, we can use these filters for them. Okay. So particularly we can use filters for our drugs which we are testing in our lab, in any form of drug discovery cases. So it is used to remove the microbes from the heat liable liquids, because we cannot autoclave them. We call them as heat liable. So if we autoclave them, these things which we are trying to sterilize, they will get damaged. Such as, for example, serum, part of the blood, they can get damaged by autoclave. Antibiotic solutions can be damaged by autoclave, and sugar solutions and urea solutions can be damaged by the autoclave. So the only option that's left with us is for filtration. So various applications of filtrations include removing bacteria from different kinds of ingredients. For example, your culture media, it can be a solid culture, it can be a culture broth, and different kinds of suspensions that contain viruses. Phage-free bacteria means phages are the viruses that infect the bacteria. Measuring the size of the viruses, we can do it by filtration. We can separate out the toxins from the culture filtrates. We can count bacteria once we pass them pass the bacteria through the filtrate, and because the filtration will stop other particles, and it will allow small bacteria to pass through, very small, which are less than 0.45 micrometer. They can clarify your liquids, they can purify your different kinds of hydrated fluids. So filtration is aided by using either positive or negative pressure, or particularly by using vacuum pumps. So the older filters were made of earthenware, means it uses the materials which are present in our earth, in our soil, or they were made of asbestos. So these kinds of filters that were using something that's coming from the earth, they were called as depth filters. Okay, so there are different kinds of filters now we will be talking about shortly. So one of them is earthworm filters. So what are these earthworm filters? Earthworm filters, they are made up of diatomicous earth, or they are made of porcelain. So they are usually baked into a shape of a candle. So when they are baked, they are shaped in the form of a candle. Okay. So different types of earthworm filters are like Pasteur's Chamberlain filter. These candle filters, particularly they are famous in France. They are made up of porcelain, that is sand plus kaolin. It's a mixture of sand plus kaolin. So similar filters that were made in Britain, they were called as Docloton. So Chamberlain's filters are made with various porosities, which can be based on their porosity. They can be graded as different kinds, like L1, L2, L3, L5, and so on. And in case of Dalton filters, they can be labeled as P2, P5, P11, depending upon the porosity size. So we also have another kind of earthenware filter, that is Berkey filter. So these are made up of Castle Gore. The Castle Gore is a fossilized this diamatous earth that is found in particularly that was is found in Germany, and they are available in different grades depending on their porosity, that is pore size. So they are V, Whale, N, normal, W, winning. So quality of these V grade filters is checked by using culture suspension, particularly of Serratia massicens, which has a porosity size of 0.75 microgram. So we can use it as a control to see whether our filter is working or not. So if it stops this Serratia massicens, it means the filter is working good for us. Another kind of earthenware filter is the Mandeler filter. So this filter, particularly being produced in America, it's also made up of Castle Gore and asbestos, and mixed with it is the plaster of Paris. Now moving to the asbestos filters. Asbestos filters, they are made from chrysotile type asbestos. Chemically, that's composed of the magnesium silicate. Okay, so what they are made, how they are prepared is they are pressed to form disc-like structures, and they can only be used once, so we cannot reuse them. So the disc is held inside a metal mount. So if we have a metal mount like here, so we keep a disc in this metal mount. Okay, so this disc, we can pre-autoclave it and put it pre-autoclave it, and then we can put it on the metal mount. Okay, this metal mount can be also autoclaved. So they come in different forms. They can be they can come in different forms based on their porosity. So they are available in different grades. For example, HPPYR, they can remove the pyrogens. You will see that many bacteria can secrete endotoxins or endotoxins like LPS, that is lipopolysaccharide, and this is particularly secreted by the outer membrane of the gram-negative bacteria. So pyrogens are those toxins which can cause fever. So we can filter such kinds of organisms or such kind of toxins. So this HPPOR removes the pyrogens, for example LPS. HPEKS is required for absolute sterility. It means it doesn't allow any microbe to pass through to obtain our liquid. So another is HPEK, that is used for clarifying. You can clarify other, for example, waste from your liquid. So it's only for clarifying. So only you should remember that only HPEKS is used for obtaining absolute sterility. Okay. Now another kind of filters that are available in the market are Sinster glass filters. These Sinster glass filters, they are particularly made of a finely grounded glass, that is fused with a sufficient amount of small particles that can help to adhere and make it a way of stopping or attaching the bacterial viruses. So they are usually available in the form of discs that are fused into the glass funnel. So if we have a funnel like this, so we can fuse the disc like this onto this funnel, and then we can put our liquids so that they can get filtered out. So filter particularly of grade 5, they have a pore dimension of 1 to 1.5 microns. So you should understand, because this is as usually, as I told in the previous slides, the bacteria has usually a dimension of 1 micron. So you will see that it can pass through it. So they are washed in running water in reverse direction. Then they can be cleaned by sulfuric acid. if we want to reuse them. So, and we have to sterilize them by autoclave before using, just like the previous filters. Another kind of filters we have which are being used is membrane filters. So what are these membrane filters? They are made up of a variety of polymeric materials. So we have, for example, we have cellulose nitrate membranes, we have cellulose diacetate membranes, we have polycarbonate membranes, and we have also polyester membranes. So the older type membranes, they are called gradocol, that is graded collodion solution membrane that was composed of particularly cellulose nitrate. Cellulose, you can understand, it comes from the plants because it is not digestible, so it has a very good tenacity. So gradocol membranes have average pore diameter of around 3 to 10 microns, so you can understand bacteria of 1 micron can easily pass through. But if they have higher dimension, then they can be stopped. The newer versions are composed of cellulose diacetate. Again, cellulose comes from the plants. It is like a collagen in the animals, so it's a very strong thing. So these membranes, they have a pore diameter ranging from 0.015 to 12 microns. So it means it can filtrate out any kind of bacteria. So and are sterilized by autoclave. So again, before using them, you have to sterilize them by autoclave before you start them for filtration. Membrane filters, they are made in two different ways. Either they are made by the capillary pore membranes, they are one type. Their pores are, they have pores produced by the radiations. Okay, when you switch on the radiations on them, it causes a pore on these membranes. Another is a Liebernith pore membrane, which is produced by the forced evaporation of the solvents from the cellulose esters. Okay, so now you have these membrane filters of different dimensions, and they can sterilize things because their porosity is very, very small. Okay, now moving to the next slide, we have different kinds of. So what are the advantages and disadvantages of these membrane filters? So let us look them one by one. First advantage is we have a known porosity, so that we know what kind of when you are dealing with different kinds of bacteria, so you can choose the porosity based on the dimension of the microbe, so you can easily filtrate it out. Another is there is no retention of fluids when you use these membranes. They can be reusable because you can autoclave them, and they are very compatible with many other chemicals that you can clean them with. But everything comes with disadvantages as well. The depth filters as earthen filters. The first disadvantage, you can say that the migration of filter material into the filtrate. So filtrate, when you part of that material that's present in your filter, can come along with it. It has an absorption on retention of certain volumes, so it can absorb or retain something. It means when we put them on in the funnel, they can retain some parts, or they can absorb some parts of or things which we want to get sterilized. So membrane filters also have a little loading capacity, and they are fragile, so you have to be handle them very carefully. A little loading capacity means if you have a funnel-like things like this, and you are putting these filters in this, it will take time for the filtrate to pass through this membrane, and you can collect it here. So it has a little loading capacity because you have to wait for a time period. Now when you talk about pore size, they are not definite, and viruses and mycoplasma, they can pass through. So only two things, because viruses are in the dimensions of nanometers. Okay, so no filter membrane can stop them. Mycoplasma are also very small as compared, particularly in the size of these dimensions. So they cannot stop it. So we have to be careful when you are using the membrane filters. You have to choose one. You cannot use filters for taking away the virus from your broth or liquid. Okay. Now another kind of filters we are having in your you will find it in your different kinds of laboratories. They are air filters. It means they can filter the air before it comes into your cabinet. So if you are working in a biosafety cabinet, okay, so you have a glass shield over it, so you can push it up and down. So this will be your working area, right? So now In order to prevent the outer air to come inside your cabinet, there is a air is coming from the upside and it goes right also. It creates an air barrier. Okay, so this air barrier can stop your entry of outside air into your biosafety cabinet while you are working with the microorganisms. So air filters, particularly when you push this air inside, this should be filtrated before entering the biosafety cabinet. And this air, when we use that air, we can use a HEPA filter, which is high efficiency particle air filters. So HEPA filters are of different types, and they are usually used in biological safety cabinets while you are working with the infectious microorganisms. For example, when you are working with the viruses, when you are working with different kinds of infectious bacteria, when you are working with another infectious material called prions, which cause infectious, which can cause Alzheimer's disease or many other neurological disorders in humans. So HEPA filters, they at least are they have very high efficiency. That is, they can remove the particles around 99.9%. They can clear the air coming into the biosafety cabinet. And for removing particles, and this 0.3 microns in diameter, so very small porosity. So examples of areas where HEPA filters are used is they are used in the rooms housing severely neutropenic patients. So they are also used in these filters also used in operating theaters where different kinds of surgeries are being done, particularly for orthopedic implant procedures where the microorganisms can cause infection. So we have to use these filters so that no microbe can come in contact while the surgeon is doing the surgery. These HEPA filters are very efficient, and their efficiency can be monitored by a DOP test. So the HEPA filters have their own lifetime. So once they are used for a particular period of time, you should test its efficiency. So you can test it by a DOP test, that is a dioctyl phthalene particle test, using particles that are 0.3 microns in diameter. So you can push these microns through this filtrate. If this particle passes it, this DOP test can be used to check. So it's used as a control or checked whether the HEPA filter is working right or not. Okay. So finally, we can come to the end of all the physical methods which are used for sterilizing or disinfection of your materials, which you will be encountering during your work and as a paramedical staff in your hospitals. Okay, so this completes your physical. Ways of the physical means of sterilizing things. The next lecture, which I will be uploading soon, will be part 2, and in this part 2 we will be talking about the chemical methods of sterilization, and the last way, that is physiochemical. So that will be a topic of my second part. So we have now completed the physical part. So hope you like the lecture, and please do comment, and you can comment right on your WhatsApp group, or you can just comment on the YouTube where I am going to upload this video. So till then, stay safe, and do practice on these lectures on the from the other. You can use other books and you can use it for your practice. So please do also comment or give your suggestions so that we can improve these lectures furthermore. Thank you very much for patiently listening to this lecture.